Hello and welcome to part 13 of my game dev tutorials. Today I'm do something a little bit different than I had originally planned. I had actually planned to do some data files and loading them. But I again was watching a StarCraft tournament, and I was just tinkering around with some HLSL and doing some tweaking to my Anti Aliasing shader. And decided that it'd be fun to do this now. I'd always planned on doing this eventually, but I just didn't know when I was going to do it. But I also find that a lot of people find it difficult to get into and hard to understand. So I'm going to do my best to explain it in a very simple manner and give a step-by-step tutorial on how to add shaders to your game. Now, this shader is only going to deal with anti-aliasing. It's not necessarily a fun shader, but it's a functional shader. And I feel like it's important to understand both anti-aliasing and how to make a shader for your program. Alright, so here we have a shader that actually doesn't do anything, but it's a good place to start because it's as simple as you can have while still rendering the result that you would pretty much expect, for the most part at least. So that's just a comment. Past that, this is you're declaring a texture that's coming in. So okay, so let me start more simple. This is a 2D shader, so essentially you're going to pass it a texture. That texture is whatever your sprite batch is drawing. So let's just quickly. Sprite batch draw all happens in basic 2D, which isn't up here. So here. So sprite batch draw, right? This is what's going to call your shader. Okay? And I'll show you how to set that up in a minute. But when that gets called, you're giving it a texture. This is that texture. Okay? This is the data that your program is passing the shader that is about the texture. And so it's a pixel shader that we're dealing with. There's no vertex shading in what we're doing. That's typically a 3D thing only, I believe. I could have that wrong. When I did some 3D stuff, you do a lot of vertex stuff. But in this case, I don't think you have access to the vertex shader in 2D. I could have that wrong. I've never used it. How's that? Anyway, this is the struct that your vertex shader is going to pass you in. And you have your position, the color, not of the pixel that's coming in. This is a color that you can pass in separately. And you have your texture coordinate. And so these three things are the standard things to pass in. You can actually pass in more than this. You can get more information from the vertex shader. Especially in 3D, you can get a bajillion things. You can create custom this, that, and the other thing. And sometimes you'll have a list of stuff that comes in for your vertex shader that's 20, 30 things long. In this case, this is all we need. Really, actually, that's all we need. But for this shader, for other ones, you'll need the other stuff. So this happens per pixel. So if you think of an image, let's pull up a quick image. Let's say this guy here. All right, so hard to see each individual pixel, but it is going to go through every individual pixel. I forget how to turn on the grid for this, but for every pixel, it's going to do what's in this shader. So that little pixel there, and these blank pixels, and this little pixel, and that little pixel, all these pixels. It is going to run whatever's in here for every single pixel. And this is the code that's going to run for every single pixel. This code here is just calling the shader and telling it which shader language it's using to compile it. This is the function name here for what is the function to call. And then this is that's just a variable. You can do a lot more with this when you get deep into learning about shaders. You can call multiple things, and I believe you can even write a decent amount of logic into here. But in this case, we're just calling a regular pixel. Again, this is the simplest kind we can get, and we are only really worried about editing here and here because we can pass in more stuff. Okay, so what's happening in here? On this line here, we are creating a float 4, which is kind of like a vector 4 from in terms of Monogame. And we are saying it's the texture color, text color, and inside text 2D, which is a function that the shader already knows. Okay, so this is shader language function. Texture sampler, that's that. Input, that's that. Texture coordinate, that's that. So the texture coordinate is an individual pixel's coordinate. Okay, but it's not an individual pixel's coordinate like, oh, this is pixel 4872, right? XY. This is a position that is between 0 and 1. So 0, 1, 0, 1, 1, 1, right? So that's how that goes. So this is a decimal number, usually a very tiny increment change. So like if you had 100 pixels by 100 pixels, this would go up by 0.01 per pixel. Okay, so that's what this is. This is getting you the texture color of an individual pixel. I just wanted to explain what each one of these things is. Again, texture sampler, this is the texture coming in from Sprite Batch. Okay? Now, next line. You actually don't need this. You could just say this here. But we're going to be editing this, and so I left it in here. This is literally just making a copy of it and then returning it. Okay? When you return that color, that is the color that it's going to draw. So if I said I wanted this to be, black, I could just make this 0, 0, 0 and leave alpha where it is, and now every single pixel will be black. Okay? I don't want that. But if I wanted to, I could do it that way. Alright, so the goal is going to be turning that into this. Still pretty small shader function. You notice that's that line. And you still return the color, but we do multiply it times a filter color. You'll see why in a minute. And that line there is here. Okay? So the rest of this is anti-aliasing stuff. Okay? What is anti-aliasing? Well, let's run the program and I'll show you anti-aliasing at work, and then we'll learn to get rid of part of it, make it better. You're never going to make it perfect, but you can make it better. Alright, so we have our program right here. We're going to move this guy down here. We want to see the tower. The tower is going to be the best example of this right now. So I'm going to just hold Alt and push print screen. And then I'm going to close it. We're going to go into Photoshop. Get a new canvas. I'm going to paste it in. And now I want you to take a look at this tower. Look how much detail is lost in that tower. Like, these lines are almost completely gone. This is dipping down in. Remember, it's supposed to look like this, right? Pretty well-defined lines. Pretty nice. And this is what we're getting. So our goal is to get some of this detail back. We've lost a ton of detail by shrinking it down. You can also lose detail for lots of other reasons. And then the other thing that anti-aliasing does is it softens the edges so that individual pixel movement doesn't look like things are jumping around. When something's moving relatively fast or in some kind of diagonals, do it a lot, stuff like that. You want to soften the edge. Now, this character has soft edges, which is why it's not a very good example. I don't know where that one is, but it already has soft edges to begin with, so not a very good example. This tower, however, had pretty much all hard edges. Notice, very hard edges. I use the pencil tool as opposed to the brush tool for most of this thing, and so you get hard edges. And that makes it a great candidate for when it shrinks, showing the aliasing. Okay? So, I don't know what else we have. That's a good example, but we'll look at other things later. Okay, so we have that. We want to make that better. So our goal is to retrieve the information that is in the texture we're passing in and get more of it on the screen. Okay? Let's go back to our little thing here. So, what we want to do, and I'm going to add it line by line, other than these. I'm going to add these all at once and then explain them. So these are things you'll pass into your shader, and I will go over this in Monogame. Monogame is going, if you don't pass these in, it will break. So you must pass these in. Not only can you, you must. Set these equal to something. This is the size of our texture, X and Y. You could make float 2s if you really felt like it. I happen to like them separate. You can do what you want. And this is the size we're trying to draw it at. So, for instance, back to our little guy here. This is a 256, I think. Let's look. Yes, it's a 256. But we're drawing the thing at, like, I don't know, 30? Something small. I mean, it's small. So we're like 1/8 of the size. And so that's a massive shrink. You really shouldn't do that very much. But this anti-aliasing shader will help even poor decisions be not so bad. Alright, so anyway, that's what those do. Filter color is the same thing as passing a color into the sprite batch. The sprite batch color, this is any filter you want to put in. That's all. So you're just coloring it. And the only thing this goes to, and we'll do this right now, is we just multiply it into the color at the very end. Right? So let's say that you wanted only the reds to come through. It would be 1001. The last one being the fact that it's solid and not see-through. Actually, you wouldn't even put in 1. You would put in the actual textures alpha. But that would then multiply the G and the B times 0 and the R times 1. So you'd only get the red colors coming through. So on and so forth. So if you gave it a filter color of red, you would get just the red parts here. If you gave it blue, it would just give you blue. The purple would just give you purpley parts. So on and so forth. So this, like for the health bar is going to be white until we pass in red here. And you'll see that in a minute. Let's see. We're going to come down to here and we're going to start our if statement. Oh, actually, let's do this, and I will explain each piece one at a time. I'm going to give you this, by the way. This shader right here, this bigger one, I'm going to give it to you. But I want to do a good job of explaining what I'm doing so that you get it. So this will be in the provided materials below. I might also provide this one, the simple, but it doesn't have much of a purpose at this point, other than because it literally didn't do anything. It took in the pixel and then put it back out as the exact same thing. So here what we're doing is we're saying this is the total size of the image. We want to know what the size of 1 pixel of that image is. So this is the pixel size. Okay? Or the pixel proportion might be a better term for it, but let's just leave it be because I'm calling it pixel size. Then we are going to get our little if statement. And the if statement goes here. Oops. And we are initializing or setting up, declaring color here because we're also at it here. Alright, so what is this doing? It's saying if the draw size of X, what we're trying to draw this X size as divided by what X size actually is less than 0.6. So if we're trying to draw it at less than 60% of what its original size is, Or, same thing for Y. Then we want to come in here. It means we want to try some anti-aliasing. This is becoming a pretty large shrink already. Now, I told you this one over here is like a ninth. So that would be like 0.11. So this is an extreme example here. But this is a point where I found that I want my programs to start anti-aliasing. If I have either been too lazy to make sure I get the right sizes from artists, or if I have not gotten enough sizes of an image to display for different resolution sizes, you know, if I've made some either lazy decisions, or I have made mistakes, that happens too, by the way. I mean, I don't sit there and calculate every pixel of everything I ever do, so there are mistakes that get made. So essentially, if it gets below here, I want to start my anti-aliasing. Okay? Instead of just taking the pixel in and putting it out with the filter color, I actually want to do something different. So, what am I going to do? This is the 40... Well, let's just put this in real quick, too. So, if it's less than 40%, I'm actually going to get double the size of the pixel size, and that'll move it over 2. And let me explain that to you real fast as well. So let's say, I'm going to zoom in here real far. So let's say I'm at 40%, and it tries to draw right here. It will not draw these two lines, and it would draw this line. So it would be here and here, potentially. Or it could be here and there, right? It's going to skip 2 lines. Or be very close to skipping 2 lines. It'll round up to skipping 2 lines most of the time. What I want to do is I want to say, hey, whoa. Let's get some more of this information in here. So if I have this line, I don't want it to skip this bright line. I want that line, right? So I want to know what that is. So I'm going to ask it about this pixel. If it's under just 60%, I'm going to ask about the pixel next to it. But in the bigger case, I'm going to ask for more information, and that'll give us a better image. And I'll show you all that in a minute. But it'll give you a much more accurate image the smaller it gets if you scale that up. You could also test for more. This is a relatively lightweight shader. So that's all that's doing, is it's saying, hey, go over 2 pixels instead of going over 1 pixel. That's all. So if it's under 40%. Now, I have tinkered with this in the past. There have been times where I've done 0.3. I've done other numbers here. This is kind of what I settled on. But I wouldn't say that I have spent tremendous amount of time testing different scenarios to figure this out. But if you use this, having the second step has a very positive effect. All right, so now what are we doing next? Let's start with just one of these. All 4 of these are essentially the same thing, but slightly different. So we are going to say, all right. So remember how we were testing, this text tests the pixel that it's currently passing us? Well, this does the same thing right there, right? That's basically the same. But instead of using the coordinate, just the coordinates passed to us, we're actually going to add our own float to it, and we're going to add the vertical size of the vertical pixel size. So that's this stuff, right? So we're going to get the pixel that's next to it. This one, in this case, is going to be above it, either 1 or 2 pixels, right? So above color. The next one is below, left, right. Let's just take them all for now. Put them in. Okay, so now we have the pixel. Let's say we're in the 60% range, and we're here. We're gonna get this pixel, this pixel, this pixel, and this pixel, and then we're gonna average them, right? And so we're gonna get a pixel that's probably slightly darker than this. Slightly lighter than this. It's gonna be a little darker than this, but we're gonna get a little bit lighter than this. So that's gonna be probably our average. We have 3 pixels of this color, 1 of that color, and 1 of that color. So average-wise, I think we're gonna get in between these 2 colors. Anyway, let's say we're here in this pixel. Above, left, right, they're all the same. So the average is the exact same. So what this does is helps bring in information. So if we were going to skip this line, which we would do on 60% most of the time, at 50% we do it every time. We would literally skip this. So it's better that here would be slightly closer to this, and here would be slightly closer to this, so that we receive that data. That data has an impact on the image. That sounds odd. You're essentially editing your picture to not be correct, but then visually it becomes closer to what you're expecting it to be. Okay, so that's what that does, right? And then what this does, right here, is that averaging. That's all it is. This line here says, all right, we'll get the texture R color. That's that one. The above R color, that one. Below R color, that one. Left R color, that one. Right R color, that one. And then after you add all those together, divide it by 5. Okay, that's your R. So comma. Now we're doing with G's. Exactly the same thing. Now you're doing with B's. Exactly the same thing. And with alphas. Exactly the same thing. Okay? That's all that's doing. So we are essentially averaging pixels that are close to the pixel that we're dealing with, and getting a better answer. Now, what you could do when you do this is do the ones right next to it, which are these ones, and do the ones that are 2 away from it. I'm doing OR because this is already 5 times the processing per pixel. So it's not 5 times the draw time, but if you're talking about the processing of the individual pixel, we're at 5x. So this has an overhead. This is not the absolute most efficient way to do this. This is a very easy way to explain it. This is a good program. It is not a great program, or shader for that matter. And I recommend using it unless you start catching lag. You start catching lag, if you can trace it back to the shader and say, I've done everything, I've made everything awesome, everything is efficient and optimized and whatever, it must be the shader that dummy over at Bathlith gave me. Alright, fair enough. But I like it. I use something similar to this as a starting point. I usually create a custom shader for the games, and sometimes multiple custom shaders for the games, just depending on what I'm dealing with, because I want to tweak it to make it look nicer. And I've been doing more and more of this with each game, which is why I get less and less issues. Like if you go back to my first game, it actually aliases all over the place, and then less, and then less, and then less. So the newest game has a lot less because I'm getting better at what I'm doing. So this is important. This is a good thing to use, and I will show you the effect at the end. This shader I will give to you. This shader I don't want to save, so no. But this is the shader we're using. To compile it, you just use the Monogame thing. You drop it in, and then you right click and say rebuild, and then it pops one out. If it breaks, it will tell you in here where it's breaking. Right now this is succeeded. But anyway, you put it in there, you process it. I have already a working version of this. I don't need to process it again. Yada yada yada. Okay. So let's jump into what we need to do to make this work in Monogame. So first, let's get the file. Give me just a second. So I want to use the exact same one I used before, and I don't remember if I messed with it or not, because I do that sometimes. Da-dum-dum-dum. Flex. All right. So here. We're not in 2D. We're not in audio. We're not in fonts. We're in effects. Okay? And in this case, we're going to add this normal effect. Again, I'm going to give this to you. Don't even stress. It's not an issue. This is just this compiled. Okay, you have to compile these things. Oh, I meant to mention, why am I using Dreamweaver for this? Well, I don't know of a text editor that actually does, an IDE that does FXs. I'm sure there is one, but I like to use it outside because it compiles separately. You actually can put it in Visual Studios, but it doesn't really do much for IntelliSense or anything like that. So I found that I can't stand just using a regular text document. It's just too ugly. And then it doesn't give me line numbers, which when you compile it, it'll tell you the line number that's broken on. So that's kind of important. And then Notepad++ I used to use for it, but I got so used to using Dreamweaver back in my website days that I just feel comfortable using it for some reason. Notepad++ is probably better. But anyway, I like to be separate because then it doesn't confuse my brain between these two. You don't need to. You can put them in Visual Studios and then compile them and then bring them back into Visual Studios and it'll work just fine. I don't. So that's a preference thing. Alright, so first things first, we are going to create ourselves a effect. So we're going to put that in globals because this is our main effect. This is the effect that runs if no other effect is running. Okay? And that one we'll just plop it in right here. So public static effect. I think I called it base effect. Let me double check that because I really do want that to be the same. I called it normal effect. Okay. So normal effect. Alright. Call it what you want. I'm trying to keep these things the same because it's confusing when I go back and forth and they're not the same. Okay, so we have this effect. Let's get that sucker initialized. And we'll do that the same way that we do textures. It's just an effect. So there will be some copy pasting here at times. I'm going to try to limit it, but typing all this out, I just don't ever type it out, so it's not something I'm used to typing. Alright, so in this case we're going to have globals dot normal effect equals globals dot content dot load effect, right? That's important. And then where it's at. So, oh, you know what I didn't do? Oh, I did. Huh. I did it without even remembering. Content copy of nowhere. So this is effects. And this is normal. You could call it base effect. You can call it whatever you want. In fact, normal is a bad name for it because that's actually a term for the vector that comes straight out of the face of a 3D object. That's its normal. You actually, it doesn't have to come straight out of it. It's defaulted. It comes straight out. You can actually tweak the normals. But anyway, way too much information. I apologize. Sticking to the point. So maybe rename that base shader or something. I don't know. In this case, I'm not going to mess with it, but you've been warned. I have no problem calling myself out when I don't do things perfectly. Alright, so the next thing we're going to do is we are going to change out the way sprite batch works just a little bit. So right here I have it deferred. If you're not running a shader program, deferred is pretty much the best. There's other ones and there's reasons to use them, but the standard use one is deferred. What that does is it says, okay, you feed me all your textures, and then I'm going to run the shader form at the end of the frame. And it tries to batch them all together the best it can and make it as efficient as it can. In order to run these shaders, you have to turn it to immediate. What that does is it literally draws it to the back buffer immediately. And that way you can sit there and change out your shaders all you want. Now, if you want to go back to deferred, all you do is close your sprite batch and open another one with deferred. Okay, it's that simple. It is going to take a lot of organizing for you to run multiple sprite batches. That's an optimization thing. It's something you get into when you're getting into the nitty-gritty. I typically have 2, 3, or 4 sprite batch runs in a game. One for the UI, one for drawing things that are not using a shader, and then drawing something that's using a shader, and then I'll have a last one that actually runs off of a render object that can do some post-processing if I wanted to. So that's 4. If you're using more than that, maybe rethink it. There could be reasons for it. I'm not saying there isn't. But that's pretty standard for a 2D game. You could probably get away with... Okay, so when I was testing this years ago, I think on a much older computer, I could run... I think it was 30-something, 35-ish sprite batches without the sprite batch itself causing lag. It's very expensive, by the way, to open and close sprite batches. Very expensive, I guess is what I'm trying to tell you. So with a decent computer a few years back, 35 started to cause lag without really doing anything. So keep that in mind. Very expensive to switch out sprite batches. So for all intents and purposes, and for right now, we aren't going to do it at all. All we are going to do is have all of our sprites drawn immediate. This is slightly less efficient, but it allows us to do the things that we need to do in order to run our Anti Aliasing. Okay, if you don't switch out immediate, this won't work. There's your... This literally took me like 2 years to find when I first started doing this. I had no idea. Yeah, I had copied this in from somebody else with deferred and never knew what it did. And then I was trying to run shaders and they weren't working, and I was trying to run shaders and they weren't working, and I had no idea why they weren't working, and nobody ever told me, oh, hey, guess what? If it's not sprite sort mode dot immediate, then hey, you can't run shader code. Oh. So there is another way to do it, which is to put it into the call of your sprite batch. Like there's one with the argument like way over, like 10 arguments down that you can feed it in. But now you can only use that shader. This is a much better way. So just letting you know. And by the way, that's why I figured out you can only get to 35. Was because I was not doing it this way because I didn't know better. So hopefully this is saving somebody some time. This is important, and hopefully it's gonna make your life easier. All right, so we've done that. We have done our initialization up here, and now we need to use it. So we have 3 main places that we draw things. We draw things in unit. We draw things in projectile. And we draw things in UI. I don't see UI. Let's see. UI. Okay, so this is where we're going to edit. Is these 3 spots. Here's where the copy pasting is going to come in, and I will explain what I'm doing, and we'll go over every line. But I don't want to type it. It's a lot. And you'll notice in just a second that I have something slightly different. Alright, so this is in projectiles. This is draw. Right before you call the draw, we're going to do this. Now, in my other one, I put it in game globals. I realized that was a mistake, and that the base one should be here. And that's because if I wanted to call this in basic 2D, which you absolutely could do, it needs to be in globals, because basic 2D's... Technically, I have access to it right now. This should be in the engine, and then it wouldn't have access to game globals. So it would only have access to globals. Because we're actually running the engine in just a file over here, it's not an issue, but it shouldn't be that way. It should be an engine so you could pass it over to a new game. Anyway. Okay. So here's what we're doing. Remember we had all of these before? So we have X size, Y size, X draw, Y draw, filter color. X size, Y size, X draw, Y draw, filter color. Alright? So here we have, that's the effect. Here's the parameters, that's what they're called. And we tell it to set value. That says float. This says float, 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 float floor for, which I told you was actually a vector for, right? In monogame terms. So we're casting them to the same thing. If you cast it as an int, it will break. But I want this to be concatenated down to an int. Because pixel shaders don't deal with partial pixels, so it's concatenated. These are already concatenated ints, so I don't have to concatenate those. I just have to turn them to floats to pass them in. So we pass those in. Hopefully you guys can see all this. It says globals, normal effect, parameters, square bracket, quote, the variable name, quote, square bracket, dot, set value, and then model bound, my model bound width, my model bound height, dems x, dems y, and then this has our color. Right now I'm just passing in white for the time being, but we'll use something different when we're dealing with the health bars. Now, this line sets all this in, and it applies it to the effect so that when you go to draw, it uses all of this information. Okay? Alright, so now our projectiles will use our shader. Great. How about we do our units? You know what? I don't think units the right spot to do this. I think our better spot would be here. So, whoops. Attackable objects. So that's like almost everything we have is an attackable object now, right? And so we've put all that in. It's the exact same thing. This actually doesn't change. Hint, hint. That means you could probably package it up as a class and, pass in the basic 2D and not have to have this. We could have a one-liner that does it instead of having 5 or 6 lines. 6 lines. But we'll get to that later. That's cleanup and making things nice and everything, and we're already running long on this video. So, we're going to leave it like that. And then we are going to come down to UI, right? That was the last one. So UI, what we have here is our health bar. Oh, we need to put it in health bar too. We'll do that in a minute. We need that to be separate. We're going to draw our health bar last, so we're going to move that now because it's important. All the text will get really wonky with a shader. So what we do is we pass in numbers that it won't mess with. Ooh. Oh, because I copied this from the other thing. Okay. Rather than passing in those floats that we were passing in, remember, like the bounds height, bounds width, all that kind of stuff. In order to make sure that it doesn't do anything wonky, we're going to pass in ones, because 1 divided by 1 is 1, and 1 is greater than 0.6, and it's greater than 0.4, so it will not enter this loop for text. Right? That's what we're trying to do. We want it to come down here and just give us a pixel for pixel output. Okay, and that's what we're doing here for the text. The text will get wonky as hell if you don't do this with the ones. And then whatever color you want the text, put it in here. In this case, it's white. Notice the black and stuff. That won't be black. I don't think. Alright, and then health bar. So, I assume I did that in my other one. Let me see what I got here. I did. Alright. Now, health bar. We're stretching the crap out of that thing. and we don't actually need to. Let's just go to definition here, so I don't have to try to find it. All we're trying to do is get the color here, right? So that is our goal, is to get the color, and we've done that, and this, and I'm going to explain why I'm doing the things I'm doing. So this is the background. It was black, so we want to pass in black. Notice there's still the ones because we don't actually care on this one. You do not need to anti-alias these rectangles, but what we do want is we want these filter colors. So filter coloring in black for the background, and we're filter coloring in whatever the color of the health bar was. In this case, it's red. Okay. Notice I didn't need to put this stuff in. If you don't need to change these parameters, then leave them. So in this case, I only need to change the red, so we're good. Okay. If that doesn't make sense, ask me in the comments. I'm happy to try to explain this better. I know it can be confusing. Essentially, once you set these, they stay set. So you don't have to continually edit them. So in this case, they're in parallel. Nothing comes in between them. So I can be quote-unquote lazy, or you can say it's efficient, and not put those four things in. Now, does it invite bugs? If I come back in here later and I do a bunch of code, I do a bunch of code right here and output some stuff, yeah, well, then that could cause a bug, potentially, if I'm not paying attention, because this may get all wonky. But in this case, they're in parallel. It's okay. We're setting it to the color it wants it to be, and we're passing in, and we're happy campers, right? Okay. So that's that. Now, let's run this. Hopefully I haven't broken everything. Okay. So I don't know if you notice, but that tower looks nicer already, I'm pretty sure. So I'm going to alt print screen, and we're going to compare. So we're going to come in here. That's what it's supposed to look like. That's what it did look like. Let's move them to where they're like the same. Alright, so I got these perfectly lined up. It is running. So you can see the pixels have changed. So these should be exactly the same. I have it pixel for pixel lined up. And you can see that, like, right in here, these lines are much more visible. So pretty much all of the lines are more visible. You also have some fading on the edges so that it looks a little nicer when it's zoomed out. Remember, this is zoomed in at 400%, so it's a little bit different. But we are definitely getting this effect. Now, maybe it doesn't seem like much. It's not supposed to do a ton. You can process the crap out of this if you want to get more information out of it, and that's all up to you. I'm trying not to give you one that's super heavy. If you want a heavier shader that does more, then you can add to it. Okay, but this, when you zoom out, you can see the difference. You really can. That one, you can barely see anything in this area here. And then this one, you can start to see the blocks again. Okay? And it makes a big difference. Little things like that. And this example is extreme, right? Remember, I told you, this is like 1/9 the size. You should never put something in your game and shrink it to 1/9 the size. I'm doing it here because it's temp art, but you shouldn't. Okay? If this were, let's say, only 1/4.5, you can see a big difference at the different sizes. Okay? So this is Anti Aliasing. This is a start of it. This is just a shader that you guys can use. I wanted you guys to understand a little bit more about shaders, maybe not be so afraid of them, understand how to get them into your game, understand how to make them work, Anyway, this was a first shader. I'll probably do more later. Not next tutorial, not anytime soon probably. But I was working on this and I figured, hey, let's put this in now so that we don't have to worry about it later. And let's get these guys a working shader. Our mouse. We'll deal with that next time. That's because it drew after we set it to black and we didn't set it for the mouse itself. So if we added another set in main, right? Oh, where's my cursor? There. So right above cursor, if we added another set, then it wouldn't be black. It was black because the last thing that draws before cursor is our quantities display bar stuffs, I believe. That's my best guess. But if you set it above it, it'd be fine. Anyway, that's this tutorial. That is the end. We have completed it. We have talked about HLSL. We have shown the differences in the anti-aliasing. In this case, I guess I should have mentioned, like, if you, I did a little mention, look, if you look at the outside, right, that little bit of information that quote-unquote isn't supposed to be there helps it transition into the background nicer and reduce the amount of aliasing your eye sees. And nobody wants to see aliasing, so keep that in mind as well. Yeah, you know, if you enjoyed this tutorial, hit that like button, subscribe, consider joining us on Patreon and helping to support these this art and whatnot. Help to support this project, I should say. Yeah, it's been fun. I enjoyed doing this one. I'm sorry it was so long. I just I wanted to go over this. I know people have trouble with it, and I want to help. So I hope you guys enjoyed it. Have a good one. I'll see you guys next time.